All right, stats. Welcome to a little video here. This is for everybody. I'm going to get some of these out, the easier ones out in a video so that when I'm with you the next 2 weeks, we can talk about more of the calculations. I'm going to do a few basic ones with you, but we want to get into finding probabilities of certain events given approximately normal distribution. So this is on page 11 in your chapter 3 practice problem / notes packets. Again, everybody needs to get this down. I'd highly recommend you start writing things down on a separate sheet of paper and labeling them well and grading our homework and quizzes. It is obvious some of our notes aren't catching up to what they need to be. Folks, we are going to be past Labor Day when I see you next. So the school year, it's officially in swing. All right, summer mode over. Let's get at it. So which of these variables is least likely to have a normal distribution? Think about that bell curve. Lengths of 50 newly hatched pythons, just, think about children on the shorter side, a lot in the middle, some on the taller side. Heights of 100 pine trees in a forest, shorter side, taller side, a lot, though, will be in some middle. So B and C, could have a normal distribution or approximate it. Income per person for 150 different countries. I mean, you're going to have a lot be really low, few in some middle, a lot. I mean, it's going to have some sort of interesting, maybe less than we think. It is going to be skewed. I would imagine it's going to be skewed to the left on that one. Though, I mean, you're going to have some countries living off a few bucks a day. This would be an interesting one because you have richer countries, but so much more on the non-rich side there. So that'd be an interesting one. All right, to completely specify the shape of a normal distribution, you must give what distribution is normal or approximately normal with a mean and a standard deviation. That is the mean and the standard deviation. All right, so you could say that some distribution is normal with a mean of 70 and a standard deviation of 2. If you see that, mean 70, standard deviation 2. So figure 3.14 shows a normal curve. What is the mean of the distribution? Just look in the middle. Go straight up. It's 2. And look at the difference there. So every little hash represents another standard deviation. So the standard deviation is also 2. So this would be normal with a mean of 2 and a standard deviation of 2. That's how we would write it. All right. The length of human pregnancies from conception to birth varies according to a distribution that is approximately normal with mean 266 days and a standard deviation of 16 days. We will talk about this question a lot. 95% of all pregnancies last between what? So this is kind of the mean plus or minus 2 standard deviations rule. We're going to go over here. I drew this out. In the middle is 266. Go standard deviation to the right. Add 16. Standard deviation to the left. Subtract 16. Add another 16 to the right. Subtract another 16. 234 days to 298 days. This would be 42 weeks. 2 weeks kind of overdue. So this is 38 weeks. So even though we try to get women to go 40 weeks for full term. A lot. The mean is, 38 weeks. So there it is. What is this? 38 weeks and then subtract 52 days. No, 32 days. My goodness. So like 33 something there. So you can kind of see 95% of pregnancy should be within what? Cool. The scores of adults on an IQ test are approximately normal with a mean of 100. We'll talk about the IQ test a lot. And a standard deviation of 15 or 16, depending on, what we're looking at. The organization Mensa, which calls itself the High IQ Society, oh, sweet, requires an IQ score of 130 or higher for membership. So what percent of adults would qualify? This is an easy one because we can do what we just did up here. So we're only looking at the high IQ side. So 50% of people have an IQ less than 100, just a fact. Okay, then you add 15, then you add another 15 to get to 130. So 130 would be 2 standard deviations to the right. Well, 2 different ways we can do this. We know that outside of 2 standard deviations is 5% total. 2.5% as a low outlier, 2.5% as a high outlier. So that's how we can get 2.5%. We can also do this. We know 50% go up to there. This represents another 34%, and that is 13.5%. Now, we'll give more of an exact answer when we get a z-score of 2 later on, but roughly 2.5%. Okay, so they're a high IQ, remember, they're a high outlier. High outlier is about 5% of the time. High outlier, because they're right on. They're right on that edge there, so 2.5%. Okay, again, have all these down. This is when we're talking about them. Let's get into our first z-score calculation. We'll talk about that on Tuesday and Wednesday of this week. The scores of adults on IQ tests are approximately normal. So again, we would say this normal, mean 100, and standard deviation 15. I could give you that in a question. You would have to know it's normal, mean 100, standard deviation 15. Corinne scores 118 on such a test. Her z-score is about what? Well, this is easy to find. Z is what the individual does minus the mean divided by the standard deviation. So the person scored a 118. That's X. All right. So X. We'll talk about making probability statements later in class. So 118 minus 100, that's 18 divided by 15. 18 divided by 15, we round z-scores to 2 decimals always. The nearest 100th, and you're going to see why. So I actually think they should put a 0 there. All right, so that's it. It's a z-score of 1.20. All right, so let's start talking. So actually, I didn't mean to write the. Let's do 322. The proportion of observations from a standard normal distribution that take values less than 1.15, that's a z-score of 1.15, is about what? So first off, that should be 1.15. We're going to look at the table, which if you're watching this video early, we haven't looked at the z-table yet. You need that all, like the next several weeks, you need that z-table. Okay, so a z-score of 0 is the middle. So half the values have a negative z-score, half of them have a positive z-score. So this is a positive z-score. I'm going to look at everyone that is below it. So this is like your percentile. If you do above average in something, you have a positive z-score, and you're an above average, above 50 percentile, okay? So there's a large area that's going to be to the left. I know that the probability has got to be above. Oh, gosh darn it. I should have gotten rid of that. That was the wrong one. It's got to be above 50%, so this can't be it. So what I do is I look up a z-score of 1.15. Now I'm going to take us to the z-table. Again, I left my actual PDF at home, so here's what I'm going to do. Now, it's very important, look up top. This gives you the area to the left, which is a probability. Table entry for Z is the area under the standard normal curve to the left. To the left. So what you do is you look up 1.15. So you go here, 1.1, and you go over to 5. 87.49. And we're going to write that down. 87.49. What 87.49 represents is the area to the left of that z-score. And that's what you want. The proportions that take values less than that is about 87.49. So you'd be in the 87.5th percentile, okay? So the probability of doing better than that, or you could say you're in the top 12.5%. There's different ways to say that, and we'll talk more about those together in class. All right, I want to do the next few. So let's talk about 323. The proportion of observations from a standard normal distribution that take values larger than negative 0.75. So negative 0.75 is on the small end here. All right, so it's like if someone is shorter, what's the probability you're going to find someone that's taller? Well, before I was a kid, I had to put on growth hormone deficiency, so the probability of finding someone my age taller than me was like about 100%, because my Z-score was way down here. So if you have, and it's like getting a low score on a test, you know, if you have a negative Z-score, then the majority of folks are going to have a better outcome than you had there. Okay, so what we do is we look on the left side now, the negative side of the the Z table. There is a T table. We look for a negative 0.75. All right, negative 0.7, and with the paper right in front of you, you'd be able to match it up with a 5. Negative 0.75, 2266. That makes sense. The area to the left is not much. Okay, not much. Now, if we're looking for a result that is greater than or equal to that or to the right of that, we need to subtract from 1. See, 2266 is the area to the left of that, but you want the area to the right of that. So it's just the complement. Why do we subtract from 1? Because the density curve, first off, has an area of 1, because we're talking about probability. Probability sums to 1. What is this? 7734. So it's B. A lot of mistakes I see in this chapter are people look up the area. Again, we're looking up the area to the left of the Z-score. So when I look up Z-scores, I'm looking up area. And they just keep the area, but we want it to the right. Okay, last one here in this section. The scores of adults on IQ tests, again, are approximately normal with a mean of 100 and a standard deviation of 15. Corinne scores a 118 on a test. She scores higher than what percent of all adults? Again, we have a Z-score of 1.20. Now, we have not looked up 1.20 yet. So we're going to look up 1.20. Again, she scores higher than what percent? So we'll make her, let's make this, she's at a 1.20. So everyone below that, she scored higher than. So she definitely, because the Z-score of 0 is 50, represents 50% to the left. So she definitely scored better than 50% of people. So is it 88 or 98? Well, let's go to the Z-table. All right. 1.2. Let's see if we can see all of this. Yeah. So 1.20 is right there. So it's 8849. And so this area represents 8849, and that is the people that the area to the left, or the people that she scored better than. So it would be that. She would be in roughly the top 12%. She scored better than 88%, though. That's what that is asking. All right, let's continue on here. This might be a good long video. Daily activity. It appears that people who are mildly obese are less active than leaner people. One study looked at the average number of minutes per day that people spend standing or walking, so not sitting. Mildly obese people, minutes of activity varied according to a distribution that is normal, with a mean of 373 minutes, standard deviation of 67 minutes. Minutes of activity for lean people had normal distribution, mean of 526 minutes, standard deviation of 107 minutes. Within what limits do the active minutes for 95% of people in each group fall? So again, 95%, that's the mean plus or minus 2 standard deviations. So for mildly obese people, there's the mean, add 67, add 67, subtract 67, subtract 67. So between 239 minutes and 507 minutes would be 95% of all people. Here's the mean. Add 107, subtract 107, subtract 107. So 312 minutes to 740, 95% of those folks. Again, they had a bigger standard deviation. That is why that happened. And this is actually the last one we're going to talk about using the Z-table. Use table A, which is Z-table, to find proportion of observations from a standard normal distribution that falls in each of the following regions. In each case, sketch a normal curve and shade the area representing the region. And I have done that on this page, so you as well, since these are your notes, and you are now a practicing college student in this college class. 328A1 is the probability, or the area here, of folks with a z-score less than or equal. I'm always going to use like less than or equal to, okay? It doesn't matter if it says greater than or less than or equal to, or greater than or equal to or less than. We're going to use that equality. Negative 2.25. So a z-score of negative 2.25, first off, there's 0. It is definitely to the left. We're talking about a small area right here. We're talking about a small area. And I'll tell you how to write the probability statement as soon as we get to them. So z equals negative 2 1/4. So what is the area to the left of that? Now, because I'm looking for the area to the left, I will be keeping that area. So negative 2.25, negative 2.25, 0122. 0122. All right, that's it. 0122 is the area to the left. So, what's the probability of having, if you get a z-score of negative 2 1/4, what's the probability of that event happening? 1.2%. It is on the low end. Now, let's take a look. What's the probability of having something that is larger than that? What's the probability of getting an outcome better than that? So we know that this area represents 0122. I want everything that is greater than or equal to that. So this is about the whole curve. So what I would do there is I would do 1 minus 0122 to get 9878. Okay? 9878. It's like if I had 50 people take a test, what's the probability of getting a 10% or less? I would hope it's 1%. I would hope only maybe one person would out of 50. What's the probability of getting better than, a 10%, a low result? I would hope that almost everyone does. All right, what do we have here? We have a z is greater than 177. So first off, you can just go to the right. That z is 0. It's like when we made number lines in inequality statements. We knew that, 8 was to the right of 0. We knew that negative 10 was to the left of 0. So I'm looking for something small here because I want the area to the right. I want to know what's the probability of doing something that is already greater than average. It's like, what's the probability someone gets a 30 on the ACT? If the average is 21, we'll talk about the ACT shortly, follows a normal distribution. What is the probability of picking someone at random that gets quite an above average result? So we go to 177, 9616. 177, 9616. So again, 9616 represents the area to the left, but I'm looking for the area to the right, so I do 1 minus 9616. I either keep it or I do 1 minus. That's the name of the game. I either keep it or I do 1 minus. That is 0.0384. And lastly, what's the area between negative 2 1/4 and 177? Well, first off, we already found the area to the left. So we know the area to the left of negative 2 1/4, a z-score of that, is 0122. And I know the area to the left of 1.77 for a z-score is 9616. So here's the thing. This is the area to the left of negative 2.25, and this is the area to the left of a z-score of 1.77. You can see that I've kind of overcounted this area twice. So what I do to find the area in between, I take the bigger area and I subtract the smaller area. 96/16. This will be easier in class as well, especially when you learn it with me and actually doing a problem. Minus 0122. How to calculate? I think it is 94. Is it 94? That should honestly not be a hard one to do. 94, I believe. All right. There it is, folks. I think that is a good video to get us into chapter 3. We're going to have some good notes. If you are in group A on Thursday, I will make you a video to catch up. Okay, I will make you a video on Thursday. Those are your notes. It is your responsibility to get those notes. I will make that at the board at school. Folks, thank you very much. This is Yak Math Videos signing out.